Hello. In this small video, we discuss fluid dynamics, which is the study of fluid in motion. So, the very important property relating to the motion of fluids is viscosity. So, what is viscosity? Let us see. For example, if you take a cup of coffee and you stir that coffee in the cup with a spoon very fast and take out the spoon and look into that coffee. As you see the surface of the coffee in motion, you can find that the coffee particles are moving around in circles, okay? But if the close observation, you can see that the particles of coffee which is in contact with the cup will be moving slowly, but the particles of coffee which is coming towards the center of the cup, as you come towards the center of the cup, the motion of the particles becomes faster and faster. So the coffee particles are not moving with a constant speed, they are moving with a different speeds, and you observe that speed of motion, you can find that the layers are moving. So different speeds means different layers are forming and those layers are moving. Now why the speed difference? When you analyze that speed difference, that analysis is now relating with something called the molecular force, called cohesive force and adhesive force. To explain that in detail, let us take the solid surface xy, and on that solid surface a liquid is flowing. As the liquid is flowing on that solid surface, some of the liquid particles are coming in contact with the solid. Those liquid particles coming in contact with the solid will be now having an adhesive force of attraction. So adhesive force of attraction will be making these particles to move with a slow speed. For example, as you see this slow speed. So those particles are now forming a layer here. And the liquid particles moving above it are in contact with this slow moving liquid particles, and there will be a force of cohesion between the molecules. But therefore, the molecules, they are not free to move above it, they are getting dragged by the slow moving particles, and those dragging will be making the particles with moving with what? Little greater speed. Like that, as we move up, you can see the layers are being formed with speeds, different speeds. So actually this layer formation is due to the speed of motion, we can assume. Okay, this is only assumption, you cannot see the layers moving. If you split that movement, you cannot see that layers are moving. This is, we are making the layers on the basis of the different velocities. So actually, between the layers of the liquids in contact, there exists a dragging force. That dragging force is called viscous force. Viscous force. And that dragging effect is called viscosity. So if anybody asks to define viscosity, you can give the definition like this. It is the property of a liquid by virtue of which there exists a dragging force between the layers of the liquid in contact when they are in relative motion with each other. Now to get more or to know more about this, let us assume that the layer here is moving with velocity v And here the layer is moving with velocity v plus delta v, for example. And between these two layers, this is v, and between these two layers there will be a vertical separation coming, let it be delta x. Delta x. That is the vertical separation. Then, as we observe, the viscous force F is found to be directly proportional to the surface area of the liquids in contact. See, though these layers are far separated, but they are in contact only, they are not getting separated. Therefore, F directly proportional to the surface area of the liquid in contact, and F directly proportional to a quantity called excess velocity divided by the vertical separation. We call this as velocity gradient. Velocity gradient. And this velocity gradient is measured perpendicular to the direction of motion of the liquid. And therefore, we can say that F equal to eta into A into delta V by delta X. Eta. Greek alphabet spelled as eta. And there is a negative sign you can give because the viscous drag is always against the motion of the liquid. So this we can take it as the basic equation for the viscous force. And from this we can define that newly introduced constant of proportionality called this eta. That eta is called coefficient of viscosity. Coefficient of viscosity. Okay. Now, what is coefficient of viscosity? So, if you want to give a definition for coefficient of viscosity, we can take it like this: that suppose I put A equal to 1 meter square and delta V by delta X is equal to 1 per second as the unit. Then F will be equal to eta. That means coefficient of viscosity of the liquid is numerically equal to the viscous force between the layers of the liquid in contact having unit surface area of contact maintained at unit velocity gradient. So this is the definition you can give for the coefficient of viscosity. Now about the unit of that coefficient of viscosity. Let us see. Coefficient of viscosity, the unit. Unit of coefficient of viscosity is that eta equal to, when I write eta equal to, it comes as F by A into delta V by delta X. Now this negative sign only shows that the force and the speed are directly, in opposite direction. That's all. So coefficient of viscosity, when I substitute for the units of these quantities, I get force Newton divided by area meter square, then meter per second divided by meter. So what I get from this is Newton, meter and meter goes, Newton per meter square second. The second will be going up. So Newton second meter minus 2. Or Newton per meter square, I can take it as Pascal, Pascal second I can see. So this is the SI unit of what you call coefficient of viscosity. Now, coefficient of viscosity, where you got the unit for that, and this unit is called, that is Newton second meter minus 2 is called decapoise. So decapoise, poisson, the name of scientist, so decapoise, 10 times poise. That's the meaning of decapoise. So the SI unit of coefficient of viscosity is decapoise, what you say. And CGS unit, we can take it as dyne second centimeter minus 2. This will be equal to poise. So 10 times poise makes decapoise. That is the meaning. Okay. So viscous force is a resisting force acting between the layers of the liquid in contact. And you might have studied the solid friction also. It's a kind of friction force. Solid friction also you studied. Now you can find some similarities between the solid friction and the viscous drag. And also you can see some difference also. The similarity is that both the frictions are derived from molecular forces. Second thing, both the friction forces acting against the direction of motion of the particles. Okay. So these are the common things relating to both. Both derived from molecular forces and both are against the direction of motion of the particles. But the main difference you can find that viscous drag is found to depend on the surface area of the liquid in contact. But solid friction is not depending on the surface of the solids in contact. Second thing, viscous drag is found to depend on the velocity gradient, but solid friction is not depending on the velocity gradient, it depends on the normal reaction. So these types of difference also you can find between them, but basically both are dissipative force or what you call non-conservative force. In both the cases there can be energy dissipation coming. So these are the basic things about what you call viscosity and coefficient of viscosity, eta. How to pronounce? It's a Greek alphabet, and eta is taken as coefficient of viscosity of the liquid.